Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CacheFly.com.
This episode of Know-How is brought to you by Shutterstock.com. With over 30 million high-quality stock photos, illustrations, vectors, and video clips, Shutterstock helps you take a creative project to the next level. For 20% off your new account, go to Shutterstock.com and use offer code KNOWHOW514. Today on Know-How, we're going to teach you all about a solar-powered Raspberry Pi. I got some evil goat mods coming for you Goat Simulator fans, and Brian's going to show you how to get the most out of Mac OS X. Welcome to Know-How. This is the Twitch show where we bend, break, build, and upgrade. I'm Father Robert Balliser.
And I'm Brian Burnett.
For the next 30 minutes or so?
Close to.
Yeah, something like that. We're going to give you some of the projects that we've been working on so that you can geek out in your own private nerd world.
Yes, we all have our own private nerd worlds.
Yeah. Now, I've been working on this for a while, ever since some of the people in our G+ community, which, by the way, go there right now. It's awesome. You should really become a member. They started saying, well, can you make a solar-powered Pi? I mean, what kind of things can you make solar-powered and have them running constantly off the grid? So I thought maybe we should build one of those things.
Yeah, well, it looks like you have enough equipment here for that, but also that's a great idea because Pis don't use a lot of power. So.
No, very energy efficient. Now, we're going to get right to this. We're going to show you all the steps that went into making this little bit of a kit. And this is very rude, this is very crude, this is very rudimentary, but it should give you enough know-how to build something on your own. But before that, I was thinking, Brian, maybe we should indulge our inner motorhead.
Yes.
I know
what
you like tinkering.
I do like tinkering. I like going fast too, but
fast.
Yeah.
Yeah. Well, you ride.
I ride a motorcycle. Yeah.
Well, you know, there's this innovation that all the cool kids are doing these days. It's called blown engines. Have you heard about that?
No.
No, come on. It's injecting more air into your engine.
A turbocharger.
Turbocharger, superchargers, right? Yeah. So a supercharger was a device that it connected to the engine. There was actually a spindle connected to your crankshaft that would turn a compressor that would drive more air into your engine.
Which means more power.
All right, because you get more air, more detonation. More detonation is more power.
Yes.
Right.
Who doesn't want that?
Who doesn't want that? And as a motorhead, you know that the way to get more power is always to force in more air.
That's right.
So, superchargers. The problem with the supercharger has always been that it robs some of that energy because you're actually using some of the engine's momentum, the crankshaft momentum, to turn the compressor. Right.
Okay.
Which we don't like.
No.
Yeah. Because it gives you power, but it takes away power. The nice thing about superchargers, though, is when you sort of jam on the gas, it spins up the compressor really quickly. So
there's no
get
lag.
Yeah, exactly. Yeah, people who have high-performance cars or who have modified cars will know that phenomenon of if they've got a turbocharger, especially like one of those old block cars.
Yes.
You hit the gas. And
nothing really happens, and then all of a sudden,
and then it kicks in. Right. Yeah. It's annoying at the least, but it's also not very good for the car.
Right.
Yeah. So we moved over to turbochargers. Now, do you know what a turbocharger is?
I know what it looks like.
Yeah. It's a little machine that goes in the engine, typically after the exhaust manifold.
Right. It uses the exhaust gases to spool up the fan that's in it, right?
Right. So it's the same idea as a supercharger, but the difference is where it gets the energy to turn that turbine. It's still driving the compressor to push more air in, but it's connected to a turbine which is in turn driven by the exhaust gas. So as the exhaust gas heads out of the car, it turns the turbine, which will turn the compressor, which will drive
force more air
in. Yeah.
Okay.
Now, the turbocharger is different from the supercharger because it actually is susceptible to that turbo leg that we talked about. Whereas a supercharger gives you the energy right away, a turbocharger is only going to get that energy when there's already exhaust gas flowing through it, right?
Right.
And that's always been a problem. The other problem is because I've got super hot exhaust gas right next to the air that I'm blowing into the engine,
right,
it tends to heat up the air.
Right, because cold air is more dense, which means you get more power from cold air, right?
And not only that, I mean, and you'll know this, if you're a motorhead, if you've really played around with engines, you know that one of the worst things you can do to your engine is to have it detonate out of sequence, right?
Oh, yeah.
Yeah, because then you're fighting the actual, like the momentum of the engine itself. It's a really a good way to blow pistons, crack crankshafts. Bad things happen to people with premature detonation.
Oh, yeah, and I can say that's happened to a few of my friends who were experimenting with turbos in high school.
Is this like your friends, quote unquote?
No. I never owned a turbo car, but I watched plenty of my friends blow up their cars with them.
Right, yeah, exactly. And that's because if the air going into the engine is too hot, the minute it mixes with the fuel, it's going to detonate. And if it doesn't detonate at the right time in a four-stroke engine, you actually have pistons like fighting each other.
Right.
It's like little Mortal Kombat in the engine.
Yeah.
Finish him!
Fatality. Head gasket blown. Yeah.
Exactly. So, have you paid attention to F1 at all?
I know of F1. I don't follow it religiously, but it is pretty interesting. And you were saying there's a pretty big advancement that Mercedes made recently?
Yeah. So they are all about the turbocharger. And actually, they use an advanced version of the turbocharger that has a small electric engine, a little motor, so that it can spin up the turbine more quickly.
Oh, that's cool.
So it's like a hybrid car, but it uses that energy to turn the compressor before the exhaust gas gets to the turbocharger, which means
reduce lag.
Reduces the lag, right? And so it gives you the reduced lag of a supercharger, but it gives you the efficiency of a turbocharger.
Sounds like the best of both worlds.
Best of both worlds, except Mercedes pushed it one step further. And this is why I wanted it on know-how, because it's really a cool advancement. And I want to work on something like this.
Yeah, you want to make your own?
Yeah. They're doing this thing called a split turbo.
Okay.
And what that means is they've taken the turbine, which is the part that's turned by the exhaust gases, and they've put it at the back of the car where the exhaust is actually going, right? That makes sense. And they've taken the compressor and they put it at the front of the car where the air is actually coming in.
So they've effectively separated them.
They've split it.
And then they can control the hot and the cold?
Well, yeah, exactly. So you can keep the hot side hot, you can keep the cold side cold, which means the air coming through the compressor is going to stay cooler. But here's the cool part. Here's the genius part. They've connected the two with a flexible shaft.
Okay.
So you can have the power stage in the back and you can have the compressor stage in the front, and they're working just as if they were together, but now you get all the advantages of a turbocharger, a supercharger, a hybrid turbocharger, and a system that keeps the cold air cold.
Oh, wow. And then so Mercedes has just been dominating then this season, I heard. Like,
yeah, no, they've been kicking everybody's butt.
Because I'm not a huge F1 expert, but from what I heard is that Mercedes wasn't really doing that well for the last few seasons, and then all of a sudden some magic happened, and then all of a sudden they're like kicking butt.
Right. Yeah, exactly. Now, Caffeine Day rightly points out that, yeah, you need an intercooler. The system that we explained is really, really simplified. Most teams will use some sort of cooling device that will cool the air coming, getting pushed into the engine. Right. But if you start off with cool air to start off with, then I mean,
you can use a smaller one, and so less weight.
Less weight, and that's one of these things where I'm sure every other team on the F1 circuit is rushing to copy the design.
Right.
But it's going to take them some time.
Well, I think now that the season's already started, they're pretty much stuck with the engines they have right now. So Mercedes is going to have the advantage for the rest of the year. Yeah. At least.
Yeah. Now, so I want to ask you, I've actually got a compressor and a turbine.
Yeah.
And I'm asking someone if they can help me build a flexible shaft. I'm wondering if maybe we could
put that in the Pope-mobile?
Charge your bike.
Charge my bike, right, yeah. That's exactly what I want to do, is just test out that stuff on my bike.
It would be a great know-how. I mean, maybe the last one, but it would be a great know-how.
Yeah. Maybe not my bike, but you don't have like an extra Pope mobile laying around or something?
Well, I'm going to Pope your ride.
Oh, right. Yeah, Pope it up. You need that bulletproof glass. And let's add a turbo to it.
Now, I do want to revisit the gearhead stuff because I actually, the world of automobiles and the world of auto tech is absolutely fascinating. I really want us to start getting into it. And I think now that you're on board, it gives us an entree to...
Oh, I don't know if I'll sacrifice my bike just yet.
Well,
but...
Burke has a bike.
Yeah, that's what I was just thinking.
Oh, that's right. He wouldn't notice if it disappeared for like a week, right?
He falls asleep downstairs, right? So.
Yeah. Yeah, he's not here. We'll do it.
We got it. Good. That's our segment for next week. Now, before we move on to the solar-powered pie segment, I thought it might be a good time to go ahead and talk about the first sponsor of the show.
Then that would be Shutterstock.
Shutterstock. Now, we welcome them to Know How. They haven't been sponsors before, and we're so glad to have them on board because we're creative people. I mean, we like putting stuff together. We like advertising what we do, and we like showing people our work. Yeah.
I just like looking at pretty pictures too. I can just browse a bunch of hippos. I can do hippo, purple hippo, and a bunch of stuff comes up. So, I mean, I could use
purple hippo.
Well, yeah.
I guess you could do that, but I'm thinking that Shutterstock is such a high-quality repository of data and of vectors, of illustrations.
Don't limit yourself to hippos.
Just hippos.
Yeah.
I mean, it's like saying, oh, look, I've got this Ferrari. Let me drive to the grocery store, right? No, seriously, folks, if you are a creative professional, if you want to add a little pizzazz to your projects, if you want a good place to start looking to drive your creative juices, well, I tell you, you gotta start with Shutterstock. Now, at Shutterstock.com, you'll find the perfect image or video for your next creative project. Whether it's for your website, a publication, an advertisement, a video, or any other type of project, you'll find it at Shutterstock. You can choose from over 30 million high-quality stock photos, illustrations, vectors, and video clips.
That's what I'm talking about.
Yeah, that's right. And even the cranky purple hippos. And Shutterstock sources images from around the world and puts them at your fingertips. Shutterstock reviews each image individually for content and quality before adding it to its library, and they add 20,000 images every day. So you're never going to run out of new images to look at. Every time you visit, you'll find something new. Shutterstock also has flexible pricing. You can choose individual image packs or a monthly subscription for the best deal. You can download 25 images a day with a standard subscription, and you can download any image in any size and pay only one price. Shutterstock gives you the images you need to bring your creative projects to the next level, and they make it easy. Thank you for the purple hippos. Shutterstock has sophisticated search tools, which means that you can search and drill down by subject, color, file type, gender, emotions, and more. Right now, our TD Alex is showing you these purple hippos that he just typed in purple hippos, and boom, there they were. You may think it doesn't have the stuff you're looking for, but with so many images, with so many contributors, they most likely have what you're looking for. Shutterstock is also shareable with lightboxes. You can save images to a lightbox gallery, then access them anytime and share them with your other team members. And they also have an award-winning iPad app, which is a really popular way to share and search through this content. Search on the go and use it to display images during presentations. Now, Shutterstock is also a global marketplace. They have multilingual customer service in more than a dozen international countries and full-time customer support throughout the week. You're not just going to get an email saying, we'll get back to you before the end of time. They actually know that you need help to get your projects done now and get them done right. Now, we just found that cranky hippo. Right now, Alex is looking for time because he's RTD, he's always worried about us running over time. But folks, if you are a creative professional, if you want the best in the business, if you want to work with a company that won a Webby, then you want to work with Shutterstock. So here's what we want you to do. You can try Shutterstock today by signing up for a free account. There's no credit card needed. Just start an account and begin using Shutterstock to help you imagine what your next project could be like, and save favorite images to a lightbox to review later. Once you decide to purchase, and you will decide, use offer code KNOWHOW514. That's KNOWHOW514. And new accounts will receive 20% off any package. That's Shutterstock.com. And for 20% off new accounts, use the offer code KNOWHOW514. And we thank Shutterstock for their support of Know How.
I just like browsing through the images.
You just like looking for hippos.
Well, how often do you get to see a drawing of a hippo in a bathing suit with water wings?
You are a strange man. All right. Now let's get to something not so strange.
Okay.
Before us is a lot of stuff.
It's a mess.
It's kind of a mess right now. Yeah, I haven't really had a chance to put anything in the project case. In fact, I've left most everything out because I want people to actually see what goes into a solar project.
Yeah, all the good little bits of it.
Yeah. Now, of course, since we're talking about solar project, I was thinking now might be a good time to lead people through the process by which they design their solar projects.
Okay.
Okay, because there is a really good system of steps that you can follow that will help you size your solar panels, size your batteries, figure out what you can and cannot power, and then also what you can expect out of a solar power system. Because I know there's a lot of people out there who think, oh, just hook it up to a solar panel.
Yeah, it should work right away.
Yeah,
right?
it just boom. It's done. No, that's not, there's just a little bit of forethought that has to go into it. Let's explain how. Okay, so the first thing I want you to see is the materials that you're going to need. Right. Of course, you're going to need some solar panels, but you don't want to buy those off the bat. You want to listen to us first so you know what kind of solar panels to look for. You're also going to need what's called a solar charge controller. I've got one right here. This one I think I bought on Amazon for like $7. And all it does is it allows you to hook up a solar panel, a battery, and then a load. Okay. And it balances between them. It takes in power from the solar panel and either charges the battery or provides power to the load or pulls battery from the power from the battery into the load. It's it's kind of your switch. This is the thing that makes everything go.
Right. Okay.
Now you're also going to need a battery, of course, because the problem with solar is it only works
when it's sunny outside.
When it's sunny, right.
Which is perfect here because the weather's been great.
Exactly. If you live in a place like California, fantastic. But, if you're living in a place that only has a few hours of sun, you are going to be depending on the battery a whole heck of a lot.
Okay.
And even in a place that has a lot of sun, I mean, there's night.
Okay. So before maybe even start this project, you should try and figure out where you're going to put your panels or...
Well, yeah.
If you're going to do like an exterior thing on your house or something.
Right. So that's one of the things we're going to look at. We're going to look at where you should be placing panels. And, honestly, whether or not a solar power system is going to work for you really depends on where you live.
Yeah. So for those of you living in a bat cave, don't try this. It's not really going to work.
It's not going to. No, you will not be happy.
Those weird billionaires out there.
Right,
yeah, you don't need solar power pies anyway.
Now, you're also going to need... for this project, some way to convert the power into something usable. Now, this is the standard cigarette
Yeah, you plug
adapter
into your car, right?
Right, so you've got 12 volts going in and you've got 5 volts going out. The reason for this is there's a lot of solar systems out there, especially sort of the smaller ones that either operate on 12 or 24 volts. I've defaulted this one for 12 volts. But you need to be able to take that and turn it into the power that's usable by your device. Now, if you've got 12-volt devices, you're good to go. Just plug it right in, and power it up. The Pi is 5 volts.
Right, it's pretty particular about that. 5 volts, 2 amps, I think.
Well, yeah, it's a little lower than that. It's really 5 volts, 700 milliamps at full load. But what's particular about this is you need to find a way to get the voltage of the system down into the voltage of the device that you're going to use.
Okay.
All right, so we'll more on that later. You're also going to need some tools. You're going to need snips.
All right. Everybody should have
wire
that.
snips. Yay, wire snips. You're going to need screwdrivers. You're also going to need this. It's a multimeter.
Ah, yes, I've seen that before.
Okay. Don't buy an expensive one. I mean, I kind of like the expensive ones. I never carry them with me because they're so dang expensive. I kind of like having some cheap ones that I know I can break.
Right.
But you just need something that's going to tell you voltage because, folks, we are working with power. And it's always good to be able to know how much power is running through a system. It's not just for building, it's a safety issue.
Yeah, that would probably be a good idea for this project.
Yeah.
So, okay, we've got the tools that we need. We've got all the parts.
Yeah.
What's next?
Well, how about this?
What?
Let's talk about your draw of the device. Now, you hinted at this before. You need to find out, whatever you're going to solar power, you need to find out how much power it draws because that ultimately is going to decide what kind of batteries you need, what kind of charger you need, and what kind of solar panels you need.
Oh, okay.
Yeah. Now, in most devices, you're going to find that in the spec sheet. So, like, for example, let's say you wanted to find what the draw was for your Motorola phone.
Right.
You could go to the Motorola website. You could go under the specs for that particular device, and it will typically say something like 5 volts, 2 amps.
Okay, yeah.
Right? And that gives you the draw.
Makes sense.
Now, for people who have studied a little bit of electronics, you know West Virginia.
Why is that?
Do you know West Virginia?
I know where it is, yeah.
No, I'm not talking about the state. West Virginia is the easiest way to remember how we determine watts, amps, and volts. It's W equals V times A. Watts equals volts times amps. I'm sorry, I know I told you there wasn't going to be any math. I lied to you. So this is how we determine how many watts something uses.
Okay.
Now, in the case of the Pi, I know that it's a 5-volt device. I know because it's running off of USB.
Right.
I also know that it's going to draw a current of about 700 milliamps.
Okay.
So if I want to know how many watts it's going to draw, I multiply 5 volts times 700 milliamps. By the way, the 700 milliamps is what it pulls at maximum. If it was idle, it would only pull 300.
Okay.
And I get about 3.5 watts per hour.
Okay.
That's how much power this thing is going to draw.
All right, but what's the difference between amperage and voltage?
Okay, that's actually, thank you for answering. That's a really good question. A lot of people get this confused, and I don't want to give you all the mathematical / electrical engineering terminology because that's going to confuse you even more.
Right.
The example I always used to use with my students is this. Imagine you have a pipe.
Okay.
Right? Imagine you have a pipe.
Right.
Continue. I hate you.
Continue.
Okay.
I didn't say.
So that pipe is 1 inch wide, right? Now, let's say that the width of the pipe is the amount of current it draws. Okay. The height of the pipe, so where it contains water, is the voltage. The voltage is all about differential. So from 0 to 5, I get 5 volts. From 0 to 12, I get 12 volts. It's what's the difference between 2 points on that electrical scale, in that electrical circuit. So if I have a circuit that does 1 volt, 1 amp, imagine a pipe that's 1 inch wide, 1 inch high, and it's filled with water, right?
Right.
Now let's say I have 5 volts and 5 volts, 1 amp. Imagine a pipe that's 1 inch wide and 5 inches high.
Okay,
right?
yeah.
12 volts, 1 amp. 1 inch wide, 12 inches high.
Okay.
Okay, now imagine we increase the amperage. I increase the amount of flow into that pipe. It's not just the potential from 0 to 12. Right. I now say 5 volts, 5 amps. So it's a pipe 5 inches wide and 5 inches high.
Okay.
Does that make sense?
That makes sense. I feel.
It's not an exact analogy, folks. So if you go into an electrical engineering class and you give that back, they're going to laugh at you. But it's actually a really good way to understand how power actually works.
No, that's a good way to explain it. Actually, my dad works for PG&E, which is the electrical company out here in California. He'd probably be very disappointed that I didn't have a better understanding, but that cleared up a lot of stuff for me.
Although, as Web8862 has said in the chat room, it's really not a good idea to put electrical wires in a pipe
into a water-filled pipe. Yeah, that's true.
It's all true. All right, now let's get back to solar. So now we have that. Now we know our draw. So this device is going to draw 3.5 watts every hour, which means that over the course of a day, it's going to pull something like 84 watts.
Okay.
So yeah, that's my day total of. And again, I always calculate for worst case scenario. That's if the Pi is running full tilt the whole day. It's going to pull 84 watts. Realistically, it's not going to run full tilt the whole day, so it's probably going to be closer to 40 watts or so, but I don't want to just assume that.
Yeah, because you can't be playing games on it all day.
Right, exactly. Well, I mean, the other thing is, whenever you're sizing solar systems, always account for worst case scenario.
Yeah, that sounds like a good practice.
Yeah. Unless you don't care if the thing shuts off.
Well, that would be kind of a pain.
Yeah, let's not do that.
Especially if you're trying to run like a little server or something on it, like a low-powered solar server.
All right, so now that we've got the draw, we don't actually look at the solar panels yet. We look at the battery.
Because that's where we're going to be storing our energy.
In fact, right now, this system is completely devoid of power. I don't have any external power going into the system, so it's just running off battery. And as you can see, the Pi screen is on. Actually, can you show us the output screen from the Pi right now, Alex?
I'm not getting it right now.
Oh, you're not? Oh, you know what? It's because I didn't hook up a mouse or anything, and.
This isn't touch sensitive?
I had it earlier and it disappeared.
Yeah, you know what?
Unplug it, plug it back in?
You don't do this. Don't ever do that to a Pi. Don't ever do that. You'll get in a bit. Okay, so it's drawing everything off of the battery, right?
Right.
What we would like to do, it'll come up in a bit. What we would like to do is we would like for this device to be able to run even if I don't get sun. So let's say I have cloudy days, I have rainy days. Right. I have to think.
Nighttime.
It says it stays night for a long time. I size my battery by how much backup time I want if I don't get sun.
Okay.
In this particular case, I've configured this so I can run one day. If I get no power for an entire day.
No sun.
No sun whatsoever.
Okay.
Or let's say the solar panel broke.
Right.
This battery is big enough
To power the Pi.
to power the Pi for one day at full load.
Cool. How did you do some calculations for that?
I
or?
did. So I mean, all batteries are rated. So this is a 12-volt battery, 8 amps, 8 amp hours, right? Amperes. Which
So
means,
12
again,
water
West Virginia,
Pi. Yeah.
West Virginia, and you know that gives me 96 watt hours.
Okay.
So it's more than a day. It's you know, it should keep me up and running even if my
At
solar
full
system
draw.
dies out.
At full
draw.
Raspberry Pi draw.
Right,
okay.
right. Now, it's up to you how you want to design your system. There are going to be some people out there who say, I only want to account for the night. And I'm going to assume that I'm not drawing full. So I'm going to get a battery half the size and panels to charge the battery.
Make a smaller, compact
Right,
version.
right.
Yeah, okay.
I'm always paranoid. I always like having extra power. That's why, I mean, honestly, this panel here can provide, in full brightness, 10 watts. 10 watts of power. So this would be enough to charge the Pi at full tilt and still give about 6.5, 7 watts back to the battery per hour of sunlight.
Okay.
Yeah. But again, we're going to talk about sizing.
Oh, okay.
All right, all right. So that gives us our battery. One quick note on this. If you're going to do this project, please, 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 please get a dedicated battery for this kind of system. You want a deep cycle battery.
Now, what does that mean?
Okay, so like the battery in your motorcycle,
Right.
that's designed to provide a lot of power, but it only does it very briefly and then it recharges.
Right.
If you take that battery all the way down to empty,
Oh,
it ain't
yeah.
coming back all the way
Oh,
up.
that's happened to me before too.
Yeah, it's
I've
a bad
left
thing.
it outside, and when it gets really cold, it gets drained all the
It
way.
gets
and
drained
I
all the
had
way.
to replace the
Or
battery.
you know, people who leave their car lights on
The lights on, yeah.
overnight. Those batteries aren't really designed to be taken all the way down and taken back up. They're designed to give big bursts of energy, and that's it. So if you buy a deep cycle battery, it's going to cost more, but it will actually last. Because remember, we're counting on this thing to power the Pi. It's going to be
Right.
draining at least halfway down every day.
Right, because there's nighttime.
sun,
But so how much? Do you know how much this one costs?
This one I actually stole from Jammer B's UPS, so I don't.
So
I don't know.
someone's computer
No,
just.
if I
goes
bought
out
this online, it would be about $12.
Oh, that's not too bad.
It's not bad.
not
Yeah,
Okay.
shipping actually hurts more than the battery.
Okay.
Yeah, okay. All right, so I've got my battery now. Now I need to calculate my solar panel needs.
All right.
Again, this is going to depend on how much power I want going into the system. Yeah, you've got the 10-volt panel there.
Okay.
That won't do it. That's not going to do it because imagine this. I need what's called the peak hour number. If you search peak solar hours for your area, you'll get a number that gives you the average amount of sunlight in your region that works out to 1,000 watts per square meter.
Okay. And
Yeah.
then that gives you the hours that.
Well,
it ranges from?
it's an equivalency number. So it's not saying, like for example, where I live in San Francisco, it's 3.6. So I get 3.6 peak sun hours. That's not saying I get 3.6 hours of sun. It says if you add up all the solar radiation that hits a certain area, there's 3.6 hours at which I will get 1,000 watts out of every square meter of space.
Okay.
Right?
Okay.
That's actually a very useful number. There's some people who will say, well, I saw the sun for 8 hours today.
So I should get 8 hours of power.
But that's not true because you know the sun comes at different angles. Sometimes you get a lot of radiation. Sometimes you don't get that much. The equivalency number gives you a really good number to base the sizing of your panels.
You can calculate how much power you're going to be able to store.
How much power you're going to need because you need to be able to input enough power, not just to power the Pi, but also to charge the battery.
Right. So then this gives you an idea of how many solar panels you need to get or how big they need to be?
Right,
or?
right. Now, so for example, in San Francisco, where I live, again, the worst case peak sun, so at the worst possible month during the year is 3.6 peak sun hours.
Okay.
Okay, so I will never go below that. So I build my system for the worst case scenario because I never want this thing to shut off.
Smart, yeah.
That tells me that if I have this, I actually have 2 of these at home. If I have 2 90-watt-hour batteries to fill, and if I have a Pi that draws 84 watts per hour, I know that I'm gonna need somewhere in the vicinity of like 120 watts generated per day out of the peak sun hours.
Okay. Yeah.
And the reason why I get to 120 is I always build in some numbers for inefficiency, because you're going to lose a little bit of power every time you transfer between devices, between the battery and the charger and the converter and the Pi.
Okay.
All right. Now, I can get away with 120 watts of solar panels per day. I don't like doing that. So instead,
is that big enough for you?
there we go. I went with this instead. I had this laying around. This is an old BP solar panel. It generates 240 watts and the nice thing about this is because it's using smaller cells, I don't have to worry about things like shade. On a lot of those really big, inexpensive cells, if you get shade on any part of the array, it dramatically cuts the efficiency of the array.
Really?
Yeah.
So what makes this one special?
This one's special is because it's using super high efficiency crystalline cells. And it's got them divided so that if I lose part of the array to shade, the rest of it actually still generates.
It's segmented.
Exactly, it's
That's
segmented, right. So this one will give me about 240 watts between 12 and 30 volts.
Okay. How expensive was this?
I stole this from Jammer.
You stole this from Jammer Beach? You don't pay for anything,
I don't
dude.
pay for it. Actually, no, there's a Jesuit house in Honolulu that doesn't have solar panels anymore. But okay.
Why are our electricity bills so high all of a sudden?
Actually, let's put this back here. So the reason why we have the solar charger is because we need something to regulate the flow of power from this solar panel into our system. So what's going to happen is it's going to go into our solar panel, and then into our solar charger. If you go to my product, it's going to plug in right here. And I'm actually simulating this with this little power supply.
Okay.
So now I've got power, 12 volts, going into this. You can't see the lights. But now it's giving me an indication that it's gone ahead and started to charge the battery.
Oh, there we go. Yeah,
there we go.
Little red and green light. Ooh, very pretty. I like LEDs.
Yeah, exactly. So now I've got power coming into the system, and it's using that power both to charge the battery and to run the Pi at the same time.
Okay, yeah, it's splitting it off. Okay.
Right, and the circuit is really this simple. The building it itself is not that hard. I have external power, I have a battery, I have a charger, I have the device I want to power, and I'm using this 12 volt to 5 volt adapter to give me the 5 volts I need for my USB device.
Very cool. Yeah. If you were going to troubleshoot, because I know you pointed out the multimeter earlier, where might you have issues, or where would you want to test if you're using it? So
if you can hold the multimeter in a place that it can be seen. So, you know, the first thing I want to check is I always want to check my incoming voltage. So I've got 11.9 volts coming in, which is decent. It's close to 12 volts. And off the battery, if I were to disconnect, I've got probably about 11.7 would be my guess. 11.5. Okay, so I've got 11.55 or so volts coming out of the battery. And then I can also check the load to find out how much is being used. You know, am I getting 11.5 or so out to my my 12 volt to 5 volt USB adapter. Okay. And again, this is where the multimeter comes in handy, because I can check the voltage coming out of a solar panel to see if it's actually generating power. What you'll see a lot on a damaged array is you'll start getting really low voltages or really strange voltages.
Huh. And that just could be like a defect of the array?
Yeah, like I had a panel once that got damaged, and it started supplying like 400 volts, but at a crazy low amperage.
Oh, okay.
And it's just something shorted inside, and it made it useless.
And if you're not getting any power at all, it's probably because Padre stole your solar panel. So.
Yeah. If you've got a solar system at home and you're wondering why you're no longer generating enough power to power your Pi, it's probably because
Padre took it.
I've got the panel.
Okay, so we've got our setup. We know how much power we'll need to power the Pi. We know the site we'll need how much power we need from the solar panel.
This is way too big. Right.
Well, maybe you could do like 4 or 5 Pis or something.
This provides 240 watt hours, which means that with my lowest possible peak sun in my area of 3.6 hours, I'm generating close to 1 kilowatt a day. This is neither the battery is big enough to store that much power, nor does the Pi draw anything like that. But I want to use the sun. I would like to use the sun in order to be able to power more than just the Pi. What I'm thinking is I'm going to be adding batteries, adding storage capacity, and then I'll be able to charge my phone. In fact, with 1,000 kilowatt, with a kilowatt hour a day, I could pretty much power all my computers.
That's pretty cool.
All my laptops, just off the sun.
Wow. Charge your cell phone and everything?
Yeah.
That's neat. But so do you ever have to worry about too much sun?
No.
Overcharging?
No, that's what these controllers are really good at. So these now this is a cheap one, but if you get a decent controller, it will condition the battery. So it makes sure it's not charging the battery too quickly, not discharging the battery too quickly, and also it will cut it off. If it reaches the point at which it knows the battery is full, some of the higher ends actually have a bank of like resistors where it will dump off the excess power.
Oh, that's neat.
Rather than driving it to your battery and overcharging it.
Very cool.
Again, this is a cheap setup. I mean, this is what you get if you buy your solar charge connector at Amazon for $7. This is actually, I broke this because I drew too much power through it. It's still kind of working, but I would never install this like in a place where I was worried about fire.
Oh, okay. Yeah. Just keep an eye on it.
In the studio, it's cool.
Yeah.
This is you.
Yeah, we have plenty of fire hydrants here.
Yeah. Now, okay, so that's enough about solar. I think in the future, what I'd like to do is I want to, of course, now that they see what's inside here, I want to put it into a project box.
Yeah.
Yeah, I kind of want to make everything a black box. I want to put. What I'd really like to do, I'd love to use the Pi to control a motor that would automatically
so
aim the solar panel.
The sun?
Right.
Yeah, that's
far
cool.
more efficient.
Yeah.
Oh, that a self-contained solar tracker. I like that.
Yeah.
Okay.
Oh, neat.
Yeah.
Yeah, we should do that.
Let's do that. But for now, how about this? We both play Goat Simulator, right?
Yes. Yes. It is a fun game.
It is a fun game.
Ridiculous.
So I was thinking that maybe the folks at home needed to have a little one-up for some Goat Sim. If you're a casual gamer like myself, you probably heard about Goat Simulator. It's a giant sandbox game that places you into the character of, well, a goat. It uses the Unreal Engine and has a lot of destructible elements. Well, there are 3 specific mods that I want to teach you how to do, starting with the Angel Goat. Now, getting the Angel Goat is very, very simple. All you have to do is nothing. That's right. When you first start the game, don't do anything. Don't jump around, don't scare anyone, just stay innocent because, again, you want to become an angel. After 5 minutes, you'll see the color of your goat will change to pure white and you'll get a halo. Now, what this goat comes with is the ability to jump really, really high, way higher than the default goat, plus it gives you a power that you can toggle. If you hit and hold R, you actually fall much more slowly than you would with a default goat. The second mod that you can activate is also very easy to get. It's the Goat Queen. What you need to do is go up a small tower that you'll find in that same paddock that you spawn in. Once you get to the top and go through that little bit of a darkness, you'll find yourself in a throne room with your subjects bowing down before you. Go ahead and jump onto and sacrifice yourself to the altar, and you'll respawn outside. You'll notice now that you have the mask of the Goat Queen. It's also the evil goat mask. Now, the powers of the Goat Queen are simple. Hitting R allows you to drop goats from the sky. Sounds a little boring, a little strange, but it actually does come in handy later on. The last mod that I think you should try to get is the Evil Goat, the Demon Goat. Now, this is located to the north and to the east of where you spawn. You're going to find it right next to the boulder that you can roll down into the party of people. You'll know you've hit the spot when you see an eerie red glow. That's the evil altar. You're going to find a pentagram on the ground. What you need are 5 sacrifices. Now, there are 2 ways to do this. The first is to be the Goat Queen, because remember, the Goat Queen, you can hit R and drop goats from the sky. Well, if you go into that pentagram and drop yourself 5 goats, you'll be able to activate the evil goat transformation by hitting Allah, by hitting the 1 key. Once the evil transformation is done, you'll be able to activate your tongues of evil, which will allow you to stick things to yourself, sort of like a katamari, a big ball of stuff, and you'll also be able to activate powers of flight. There's also another way to activate this mod, and that's by grabbing 5 innocents from that party. Go ahead and headbutt your way in and grab 5 of the guests, one at a time, into that pentagram and do the same thing. Either way, you'll get your demonic powers. Now, I like to have all 3 of these mods activated at any given time because, well, it allows you to create a lot more mayhem. You can jump high, you can drop your demonic thrones from the sky, and you can fly around the map. Give these mods a try, and in no time at all, you'll have mastered Goat Simulator. I'm Father Robert Balasaire, and that was a quick tip. admit it, you've done that way too many times.
Oh, yeah. And I like that you're doing tips on it because we introduced it, a few shows back, and maybe people didn't know about some of that stuff. So it's funny.
It's the kind of game for people who maybe are tired of just the standard shoot 'em up type stuff.
Yeah, you just want to goof around.
There's no way to win the game. It's just how much mayhem can you cause.
And for a priest, you caused quite a bit of mayhem.
It's kind of like my outlet.
Yeah, keep it in Goat Simulator.
I like
please.
to read YouTube comments and then I play Goat Simulator. And just say, oh, write a comment about me, will you?
That's how you vent, huh?
That's how I vent.
Okay, because you wouldn't like you angry.
No,
yeah.
No, you don't want to see me angry.
No. But
Brian, okay, let's get away from Goat Simulator and talk about something truly useful because you've got some, I'd say, life-changing Mac OS X tips.
Oh, well,
Padre,
what?
This is Alex here in the director's booth. We don't have time for this again.
Whoa.
What?
We ran long in the first segment. I know, but you're running a little long. We have to hold.
Where are you, dude? Show yourself. Don't be a
come on,
coward.
just
This is ridiculous.
Hold on. Let's get my camera
We've got
going
the
here.
full.
See out there?
Oh,
yeah, see,
God.
there I am pushing buttons on the TriCaster.
Oh, no.
Here.
Are you kidding me?
Oh, no,
I can't
he's
do it. See, there's a T-bar. We just got too much going on over here. We just don't have time to do this.
Hold me back, Brian. Seriously, hold me back, man. I've just got.
Oh no!
Oh.
He's unleashing the full
just because
power of
he's
the
got all the
TriCaster.
buttons in front of him, he thinks he's got all the power.
He's gone to the dark side. Yeah, maybe we shouldn't mess with Alex.
I actually.
He's got a lot of power over there.
Does.
Whoops.
He actually controls the stream.
Didn't mean to blow that thing up.
Did you just feel 1,000 souls scream out?
1,000 geeks crying out that they're not going to get their Mac OS X tips.
Maybe next week.
Forget it. No. You know what? I'm done.
We'll try for next week.
Fine. Whatever. And you know what? You got to clear this with him ahead of time because I'm tired of getting our segments cut.
You saw the power he wields. It's up to him.
Ladies and gentlemen, I'm sorry. I'm not going to go ahead and press against the Dark Lord here, so we're going to have to call the show. We've had a lot of information. In fact, way more than we talked about. All the solar calculations I actually have in the show notes, so you're definitely going to want to go there after the show is done. We're going to post this up in about 3 hours. Where can they find our show notes page?
Well, I'm glad you asked, because you can find those at twit.tv/KH, and as far as show notes go, they're the best.
They're the best. They're the best in the biz, right? We give you the step-by-step, so don't freak out if you weren't able to follow us during the show. I know it's a lot of information, but read up a little bit, and I'm sure you'll be solaring your Pi in no time. Also, if you are concerned, if you really do have a question about how you make this thing work, you can always email us at knowhow@twit.tv. That email will promptly be put into my spam folder.
And we will never read it.
We will never, ever read it. But if they do want us to read something, where should they go?
Well, you can go to our Google Plus community. We have over 6,000 members, and pretty cool place to post questions, and a lot of people have great responses. But if that's not enough for you and you use Twitter, you could always follow Padre.
I'm at PadreSJ.
And I'm at cranky_hippo.
Yeah.
So, and we get those right away.
Oh, and by the way, if you'd like to vent as to why our tips keep getting cut off. Last week was Windows 8.1 tips. This week
talk too much.
Well, please go talk to the Dark Lord himself. You can find him on Twitter at ANELF3, ANELF3. Vent to him. Tell him that, dang it, we want our full hour of know-how because I'm sick and tired of prepping stuff that doesn't go out on stream.
Unlimited power.
As for us, I think that's going to do it. Make sure that you join our G Plus page. Make sure you give us the feedback. Make sure you tell us what you like seeing in the show and what you don't. And we'll keep giving you all the Cranky Hippo Padre SJ goodness.
We do what we can. Now that you know how, go do it.
Bye.
Oh, no!
No, Alex, don't push the button.
Alex, you already blew up one planet.